The tremendous growth in renewable energies, especially in the north of Germany, is currently causing bottlenecks in the transmission grid. New power supply lines are required in order to distribute the overcapacities in the north evenly over the whole of Germany. The DC cables planned for this will in future mainly be laid underground. This in turn leads to new requirements for the transmission system operators with regard to route plans and designs. To this end, Herrenknecht has worked with the transmission system operator Amprion and the Institute for High Voltage Technology at the RWTH Aachen and developed the new e-power pipe method. With the e-power pipe technology, protective pipes with smaller diameters can be installed quickly and safely underground, with drive lengths of more than a kilometer. The trenchless method is based on proven microtunneling technology and allows the efficient installation of individual cable protection pipes, taking into consideration all criteria with regard to cost-effectiveness, safety, and construction time. The e-power pipe method involves three main components: a jacking frame, the tunneling machine, and jacking pipes. The drill carriage is moved by electric motors at up to 5 meters per minute. The maximum achievable thrust force is 350 tons and is transferred to the launch shaft via gripper cylinders. For the launch process, the TBM is placed in the jacking frame with the aid of a traverse. The water circuit is connected to the machine, and the power and data connection is established by a specially developed cable. With the aid of the electrically driven drill carriage, the TBM is then pressed into the ground. 3 hydraulic motors drive the cutter head, which rotates at up to 25 RPM to remove the soil. The slurry-supported machine technology allows tunneling in soils with high water content. There's no need to lower the groundwater. A cone-shaped crusher breaks rocks and other obstacles along the tunnel alignment to grain size for transportation. The excavated material is then extracted via the hydraulic circuit and the central slurry line. The suction effect of the slurry line is achieved by a specially developed jet pump at the rear of the machine. The jet pump is powered by a propulsion jet. Its extremely high discharge velocity from the jet nozzle creates a negative pressure that sucks the suspension from the slurry line. The jet stream and the suspension combine in the mixing chamber and are passed on to the slurry line. At the launch shaft, in a suspension plant, the excavated material is separated from the suspension, which is then fed back into the slurry circuit. The jacking pipes are lowered one by one into the shaft and joined together by high-tensile plug-in sleeves. The connection is made by 2 chains, which are inserted into the plug-in sleeve. This allows pipe changes to be carried out in under 10 minutes. The connection closes the slurry circuit and creates a high-tensile pipe string at the same time. A jacking frame transfers the required thrust force to the jacking pipes and the tunnel boring machine. The position of the machine is determined by a surface-controlled measuring system in combination with a gyro compass. A sensor in the tunneling machine is oriented to a magnetic field on the surface. This is created by a powered cable along the alignment. The magnetic field determines the position of the machine. This means that, in combination with the gyro compass, minute deviations from the normal axis can be recognized at an early stage and corrected using the steering cylinders. After a successful breakthrough, the machine is pushed into the target shaft and detached from the jacking line. Recovery is then effected from the target shaft using a traverse, and the machine can be prepared for the next bore. For the installation of the protective pipe, the jacking line is attached to a tractive connection in the target shaft. The prefabricated protective pipe is then suspended from this by means of a vortex before entry. The jacking pipes are removed in reverse order and temporarily stored at the launch shaft for the next drive. During retraction, the pulling force is constantly checked directly on the protective pipe to prevent damage from overloading. At the same time, while monitoring the volume and with the help of an earth pressure sensor, the annular gap between the protective pipe and the borehole is carefully filled. Cable protection pipes with smaller diameters can be quickly and easily installed underground using the trenchless e-power pipe method by Herrenknecht. Thanks to the precise control, drives of over a kilometer are possible, even with low overburdens. This method is thus a ground-conserving alternative to conventional open-cut installation.